Let us discuss about the Archimedes principle. The Archimedes principle states that when a body is partially or wholly immersed in a liquid, it loses some weight. The loss of weight is equal to the weight of the fluid or the liquid displaced by it. How we are going to prove that? We will take a beaker, fill it with a fluid, and we will immerse a body wholly into it. The cross-sectional area of the body is A and the height is h, and the density of the liquid in which it is immersed is equal to rho. Now, the height of the liquid above the top face is equal to x, and above the bottom face is equal to h plus x. If we take these vertical faces, the pressures here will be equal and opposite to the pressures on this vertical face from here. So these will cancel each other. But here thrust F1 on the top face and the thrust F2 on the bottom face will be different, because here we cannot neglect the gravity as is neglected in the Pascal's law. Here we are not neglecting the gravity, so the thrusts F1 and F2 are different. Now here at the top face we can easily see that the pressure P1 is equal to rho g into x1. So the thrust on that, if the cross-sectional area is small a, is F1 is equal to P1 into A, that is rho g x into A. Rho g x into A. Similarly, at the bottom face, the pressure P2 will be equal to rho g x plus h, as h is the height of the body which is immersed wholly in this fluid. So F2 will be equal to rho g into x plus h into A, where A is the area of the bottom face of this body. Clearly, we can see that F2 is greater than F1. So F2 is greater than F1. So the difference in F2 minus F1 is equal to rho g into x plus h into A minus rho g xa. That on calculating gives us rho g into h into A. Rho g h into A. Now, if A is the area and h is the height of the body, so the volume of the body is equal to A into h. Now, the mass of the liquid displaced is equal to density of the fluid into the volume of the body. The density of the fluid is rho and the volume of the body is V. So we can say that M is equal to, giving the value of AH in place of V, we get that M is equal to rho into AH. Rho, the difference in the forces F2 minus F1, F2 minus F1, giving the value of M to rho into H into A. So F2 minus F1 is equal to mg, where mg is the weight of the liquid displaces, which proves the Archimedes principle. Therefore, the F2 minus F1 is equal to the weight of the liquid or the fluid displaces. So F2 minus F1 is equal to mg. This is the loss of the weight of the body is equal to mg if we have the true weight of the body is equal to m into g. So the observed weight will be equal to true weight minus this upward thrust, that is F2 minus F1, that is equal to F, that is equal to Wt minus, but this F is equal to the weight of the fluid displaced, so that is true weight minus mg, or that is equal to mg minus mg, where capital M is the mass of the body immersed and small m is the mass of the fluid displaced. This is all about Archimedes principle.